All right, so I just wanted to give you an example in case you're stuck. So a particle travels along the y-axis according to the position function y of t cubed minus 7t squared plus 8t plus 1 during the interval 0 to 5 where t is in seconds. So first thing I noticed that y is a polynomial, so it's going to be continuous and differentiable everywhere, but we're just worried about from 0 to 5. And so that means, okay, I have no idea if this is going to be asked or not, but the particle, y, is going to have a maximum somewhere on 0 to 5. Maybe it's at 0, maybe it's at 5, maybe it's somewhere else. Let's see what we have to do. So at t equals 1, is the particle traveling up or down? Give a reason for your answer. So, well, is that about position, velocity, or acceleration? Traveling up, that sounds like velocity. So velocity is going to be y prime. So the velocity function is 3t squared minus 14t plus 8. And well, I assume positive velocity, it's got to be, is going upwards, and negative velocity is going downwards for this particle. So I'm just going to figure out what v of 1 is. That's going to be 3 times 1 squared, 3 minus 14 times 1 plus 8. So that's going to be negative 3. So at t equals 1, the particle is, it says traveling, I was going to say moving, traveling downwards. V of 1 is negative. That's definitely a reason. I'm feeling good. Moving on. When does the particle reach its maximum height on the y-axis? Okay, so this is, all right, we just want to find a maximum. Let's see. So first, I'm going to have to find where the first derivative of something changes from positive to negative, and we want the maximum height. That's a maximum position. Okay, so part B, I didn't label part A. Part B, let's see, when does the particle reach its maximum height on the y-axis? So we will figure out, okay, we already said the position function is continuous. We need to look for a change in sign of velocity. We already have velocity, so we're going to set velocity equal to 0. Can I factor that? Well, let's see here. There are factors of 24 that add up to negative 14. So this has got to be a 3t, and this has got to be a t. The signs are both going to be, let's see, negative, so that would be, I'd be adding to get 14. So maybe 3 times 4 is 12 times plus 2 more. Okay, so that works. Let's see, so that'd be 3t squared, negative 12t minus 2 more t's is negative 14t plus 8. Okay, so that I have this equal to 0. T is going to be equal to 2/3. T is equal to 4 when the velocity is equal to 0. So I'm going to make a sign chart. Back here, closed intervals, we're going to have a 0 to 6. Put 4 on here. Put 2/3 on here. These are t values, and this is sine of v of t. You may want to write y prime of t. Who knows? So let's see. I'm going to substitute numbers back into v of t and figure out if this thing is positive or negative. You might want to look here as well. So for a number greater than 4, like 5, 5 minus 4 is positive. 3 times 5 minus 2 is going to be positive. A positive times a positive is positive. I'm guessing v is going to be negative here. So let's see. How about 1? 3 times 1 minus 2 is positive. 1 minus 4 is negative. A positive times a negative is negative. So, all right. What about at something just larger than 0? Something just larger than 0, so like 0.01, 3 times 0.01 minus 2 is negative. 0.01 minus 4 is negative, and negative times a negative is positive. So let's see. We want a maximum height. Maximum is where the first derivative of the height function changes from positive to negative. Okay, there we go. So at t equals 2/3, the particle reaches its maximum height. Oh, not ever, maybe, who knows, on 0 to 5, since v of t changes from positive to negative at t equals 2/3. Now I'm just realizing, so if v is positive, negative, and then positive, maybe I got this wrong. Uh-oh. So I actually have to go back and check. I need to make sure that, well, look at this. So the height of the particle is increasing, decreasing, increasing. 2/3 is definitely a local maximum. I'm sorry, at t equals 2/3, the particle is at a relatively maximum height, right? It's higher here than it used to be, it's lower than it used to be. Okay, and over here it's 6, that might also be, in fact it is a local maximum. I need to put 6 into y, I need to put 2/3 into y to see which one is higher. Apparently my time is up. So I'll just finish out what I was about to do. We need to do y of 2/3, and that's going to be 2/3 cubed minus 7 times 2/3 plus 8 times 2/3 plus 1. All right, well, I really don't want to do that by hand. That seems ugly, but I'm going to factor out a 6 squared, so that's 36 times 6 minus 7, negative 1, plus 48, plus 1. And so that'd be 48 minus 36 is 12, plus 1 is 13. Oh, I really don't want to do this. So let's see, 8 over 27 is less than 1. 14 over 3. Ooh. Plus whatever that is. Let's see, 16 over 3. Oh, that's not bad. Oh, did I miss a squared? Crap, I did miss a squared. So let's see, that's 428 over 9 plus 16 over 3 plus 1. So is this number greater than 13? Well, let's think about this. So 16 over 3, that's like 5, plus 1 is about 6, plus less than 1 is nowhere near 13, and I still have to subtract. I'm not going to figure out what this is. I'm just going to go ahead and realize I was wrong and cross this off. At t equals 6, the particle reaches its maximum height. Let's combine answers here.